Let's talk about interfacing your Continuum or ContinuuMini to a control voltage-based instrument like a Eurorack modular, perhaps a Moog synthesizer, anything that will take a CV input. You'll have two choices with the Continuum or ContinuuMini. The first is the 4-channel CVC available through Haken Audio. This allows you to use 4 channels of W gate X pitch direction, Y front to back motion, and Z pressure, 4 channels worth that you can connect up to your modular in different ways. This is probably the better choice for Continuum users when you want to play polyphonically. However, ContinuuMini owners are probably better off buying the micro CVC since that's a single channel device. It operates very much like the CVC does. However, it's a Eurorack based module that goes right into your rack, and then you can connect that right up to the Continuum and you're on your merry way. This has one extra option, the F output, that will track whenever you are pressing on the fingerboard. So here's a more detailed view of the CVC. Again, 4 sets of W, X, Y, and Z outputs. This can be programmed through the Eagan matrix in various ways, or it can be defaulted so that it operates without programming anything into your matrix. How do you connect things up? For the CVC, you'll want some kind of MIDI interface that you normally use connecting to your computer for Eagan matrix support. That'll have a MIDI DIN output that you'll connect up this way. The output of your interface will go into the input of your Continuum, and the MIDI output of your Continuum goes into the CVC. The through goes to the in of your MIDI interface, and that should allow you to boot up and get your blue LED validating that everything's connected okay. The Continuum manual also has a setup that shows you how to connect this up if you're also using the Eagan Matrix Expander, but likely not many people are going to be using CVC and the Eagan Matrix Expander, so I won't go into any detail there. Now, for the ContinuuMini to CVC connection, you're going to have to create your own cable or try ordering one through Haken Audio. Here you'll need a TRS jack on one end that'll connect to a MIDI DIN on the other. Basically, you can do 2 things. Create a little adapter cable, that's what I did, that uses a TRS going to a female DIN, and then I just connect up a standard MIDI cable to that right into the CVC. Or if you want, you can create your own MIDI cable with TRS male on one end and MIDI male on the other going into the CVC. But as we said before, I suspect ContinuuMini owners likely are not going to have CVCs, as it's not a cost-effective option since the ContinuuMini is only a 1-channel device, 2 at best if you're playing duo tactically. So in that case, if you have a ContinuuMini and you want to support CV, I would suggest you get the micro CVC. You only need 1 card here, the master, and that'll connect up with the cable you'll get from Evaton Technologies. Just specify when you're ordering whether you want a ContinuuMini cable or a Continuum cable, and that plugs right into your ContinuuMini, and it screws onto the faceplate of the micro CVC. You only have to remember that on the pedal input you set your I2C option to 1, which supports CV operations. If that's set to the default of 0, expecting the normal pedal, your CV operation will not work correctly. So next, we'll talk about how you interface this and use it. You don't need to program anything into the matrix to use the 4 channels of CVC, but you will want to do a few things. Number 1, you're going to want to set your CVC up to a voltage that corresponds to what your Eurorack or other synthesizer expects. You're going to likely want to set your note priority to always play the lowest note. Why you want to do this is if it's set to the default, once you start playing, you won't be able to remember what channel is coming out mapping to what finger, and you'll get confused very quickly. If you set note priority to low, whenever you play monophonically, The lowest channel on the CVC will always be output, and as you add a voice polyphonically, then channel 2 will come in, channel 3 will come in, etc. It's very easy to make the correlation of your fingers to CV channel outputs in this case. So I suggest, unless you don't want to use some kind of random like CV approach, set no priority to low. And then, since the CVC only has a max of 4 channels to output, I suggest you set your polyphony to base 4, not 4 plus. If you're set higher than polyphony 4, the CVC is still only going to output on 4 channels anyway. As we said, one of the things you're going to want to do is map the CVC voltage to the voltage of the device that you want. There's a lot of options here. You can see a basic 10 volt option, 5 volt options. There's options for a Voyager, a Buchla, and other things. Set it to the one that you'll use corresponding to your instrument. For Eurorack, I find 10 volt option normally is fine, or maybe you want to use a 5 volt option. That you can experiment with. Some other things to set on your global options. Here we haven't set any Eagan matrix programming yet. Set polyphony to base 4, set note priority to low. You can set whether Z is going to use linear or a squared function when you press. There's also an option for layering. Here, if your polyphony is 1 and you have layered selected, the gate X, Y, and Z for each note will be available on all 4 sets of CV outputs. And if polyphony is set to 2, it'll be available on the first and the third. We'll go into that a little later, because when you program through the matrix, a similar set of mappings will apply. Then there's a bass voice option. I don't really use this much, but this control signal generates by the CVC can be shifted to different outputs. If the bass voice is 2, 3, or 4, you can set which the main bass voice is generating CVC output on. And another option is if you set the internal split sound below or sound above split point, you can get the continuum to play its audio output on one half of the split and CV coming out on the other. Now, if you want to program the CVC through the Eagan matrix, you have 2 options. There's a CVC set of programming options on the B bank. There's also a set on the C bank. I suggest you use the ones on the C bank, because that will actually override B if you have B set. That'll allow you both banks A and B to be used for other sounds. If you do set a value in the CVC settings for the matrix, you'll see the CVC option here goes from its default 10 volt or whatever option you set to CVC via the matrix. By the way, if you hover over this, you'll get a little indication that you're actually connected as well. Let's take the first use case. We'll create an empty preset, no Eagan matrix programming, and we'll set the default CVC options to 10 volt linear Z. We'll set note priority to low, and we'll set polyphony to base 4. This is a very standard setting. I'll be able to play my continuum, and the CVC will play up to 4 voices if I'm holding down 4 fingers, and I can then use that CV output to do whatever I like with. We're going to use the Synthesis Technology E370 quad morphing VCO as the input source for our CV. This is an outstanding Eurorack module that basically, not exactly, but for all intents and purposes, it has 4 E352 cloud terrarium modules in one Eurorack module. This perhaps is the mother of all wavetable oscillators. I can't imagine anything being better than this. So in effect, we have 4 of these wonderful oscillators that can be independently controlled through CV. Each one has a 1 volt per octave input. The outputs will send to our outs. Now, each of these oscillators has an X and a Y input. Don't confuse this with X on the continuum. This is really a 2-dimensional matrix control that allows us to determine which of 64 possible wavetables I'm going to be on at any particular time based on an X voltage and a Y voltage. Now, one of the great things about this module, it has many modes, but one of the modes is it can smoothly morph between these wavetables, and that's the mode we have it set to now. So depending upon my X and Y voltage, I could be in any one of these wavetable waveforms. Now, how might I use this in practice? As we said before, I'll take the X 1 volt per octave output of the CVC, and I'll connect that to each of the 4 oscillators 1 volt per octave inputs. The outputs I'll send to a voltage controlled amplifier so I can directly control them with CV. Why do I want to do that? Because I want to use the Z on the continuum as my envelope. I don't want to have to use an envelope generator, which I could, to control envelope of each of the oscillators. Finally, I'm going to use my Y parameter to control the E370's X and Y matrix controls. I can either send Y directly into X of each of the oscillators to control X. If I did that, I'd be controlling only the X-axis because Y would be set to its default of 0. Or I could do the opposite. I could take Y and send it into the Y matrix control of the E370, and in that case I would be basically controlling the waveforms in the Y column. But what I'm going to do is something a little different. I'm going to take a multiple, which basically is a signal splitter, and I'll take Y and I'll split it and send it into both the X and the Y matrix inputs of the 370. And that will allow me to basically get the diagonal sets of morphing waveforms. Now let's go to the video and play around a bit. So I'm connected up now to my E370, and let me play a note on the fingerboard. If you notice, the light for channel 1 is active, and as long as I only play a monophonic line, only channel 1 will play. If I play another note, the light on channel 2 lights up. Channel 3, channel 4. 3, 2, 1. This is why setting it to low makes sense, because the notes map channel-wise to the positions I'm playing on the fingerboard, and I can associate what notes from what finger are being sent out to what CV channel. If I had another mode set, I wouldn't be able to do that as easily. Now, I've set this E370 up so that the matrix X and Y modulation morphing is off, so I only get the base triangle waveform out right now. But because I'm hooked into the VCA and I'm controlling the volume of the VCA through Z, I can get that very nice subtle dynamic variation that would be very hard to do any other way on the modular, and what makes the continuum so great. I've also set this to squared Z actually instead of linear, which I find is a little bit more expressive. Let's take a look at our waveform now. I'm only playing the base triangle waveform because I'm not applying Y to either the X parameter or Y parameter for modulating between the waveforms. Let's turn on the X modulation that I have Y, which is split out to control both the X and the Y E370 modulating functions. So now I should morph through these set of waveforms as I increase my voltage by moving Y from bottom to top, from triangle all the way through these different more complex triangle sawtooth-like waveforms. Sounds kind of like a filter, but it's really morphing between waveforms to do this. And now I'll morph on the Y column from this triangle sound through the PWM sounds, resonant sounds, female vocal ooh, male vocal ooh, to a ringing pulse, to a sine burst, to a sine wave. So this module, you can put all different kinds of waveforms in for your morphing. And now when I play this, I can almost hear that resonant ooh sound in there. And if I want to, I can apply both X and Y modulation, and because I've split the Continuum's Y signal out, it will now play on the diagonal and Y function. Different set of waveforms, and of course one of the nice things is I'm never really going to be playing on a flat plane, so my Y voltages will vary a bit depending upon where my fingers are, and that will actually cause different waveforms to be played for each finger in this case. Let's take a look at what happens when we want to program the CVC. If I set a value in the matrix, I'll now be under matrix control. And if you notice, there are two sets, WXYZ, WXYZ, of control options here, and those work as follows. If I set something in the first set of these, it's going to affect channels 1 and 9, 2 and 10, 3 and 11, and 4 and 12. Right. If I set something in the second set, that'll affect channels 5 and 13, 6 and 14, 7 and 15, and 8 and 16. However, a special function has been applied here. If I only use the bottom set of these, they will apply to all channels. Let's see what happens then. We'll set W to a formula. Basically a formula that's going to be equal to 1. What this will do is send a 1 volt output. Since I'm setting gate, it will turn the gate on for all of my channels. So I'll set A in my matrix. If you notice, all the lights are on now because W is being sent out 1 volt on all of the channels. I have a cable connected from W to a voltage monitor up here. You probably can't see it in the video, but that's coming out now 1 volt on the first channel. If I take it to the second channel, it's also 1 volt, also 1 volt, and also 1 volt. All right. So if I have something set in both the lower and the upper sets of W, X, Y, and Z controls, the first 4 will apply to channels 1 and 3. The second 4 will apply to channels 2 and 4. If I remove the second set, these will apply to all the channels. I've set B here to be 2 volts. A is 1 volt. So I would expect channels 1 and 3 to be 1 volt and channels 2 and 4 for gate to be 2 volts. I can test that. I can see I have 1 volt coming out on channel 1. I have 2 volts coming out on channel 2, 1 volt coming out on channel 3, and 2 volts coming out on channel 4. And the same thing would apply if you programmed X, Y, and Z. Let's end by talking about the micro CVC from Evaton Technologies. Here it is up here. It's a 6 HP Eurorack module. Goes into your Eurorack setup. It's got 5 sets of outputs, an F output that tracks when your finger is on the ContinuuMini or Continuum fingerboard. W for gate, X, Y, and Z, exactly what you would expect from the Continuum. As we said before, this is an ideal unit for the ContinuuMini since it's typically only 1 channel playing anyway, and the micro CVC is a 1-channel device. You can get a second unit. It connects to the first, I think, through a ribbon cable on the back. That second unit's a slave, and it'll allow you 2-channel operation. I only have the one here, however. So to test this up, we'll do something a little different. We'll more look at creating some kind of an effect and trying to create distinct oscillator tones. We'll take the X output and we'll program all of this in the Eagan matrix. what I've done here is I've connected up X to a multiple that will allow me to copy the signal. One of those I'm going to send into the single oscillator that I'm going to output through a reverb unit through the voltage controlled amplifier like we did before. And the second copy of that X I'm going to send as the 1 volt per octave input to a second oscillator, and I'm going to use that oscillator to send it back into the first as an FM modulator. Then the Y output of the micro CVC, I'm going to control the Y axis of my morph the way we did before, and Z I'm going to send into the VCA like we did before, so I can control the output volume through the Z on the fingerboard. Now let's take a look at what we did for programming this, because we want to do this under matrix programming control. What I've done here is I've created a formula for X. Now remember, the formulas that you're creating in the CVC bank are going to want to be output as volts. So the units that you scale everything to, you need to think about how that maps to voltage that you're going to send out to your unit. In some cases in the Eagan matrix, you use very small or very large values. They won't really be very applicable for a lot of what we're doing here. So on X, I create a simple formula outputting X as octave, and on that I modulate it, basically add a shape generator based sine tone to it that I've set up to map to a oscillation that's controlled by pressure. So on E here, you can see I've got a little formula that I multiply times Z. As Z increases, as pressure increases, the speed of this oscillation will increase. Finally, on Y, you'll notice that I have a step function where it'll be 0 at the beginning, and then it'll go right to a high value, and that will basically let me morph between one sound and another on low Y and high Y on the ContinuuMini. Remember, on the ContinuuMini you don't really have that much of Y space, so I try and give a sharp cutoff if I can, because you really don't have much control between the bottom and the top of Y. So here's what it will sound like. As we press harder, we get louder and faster. And as we press top of Y, we change timbre because I've changed to a different waveform. Kind of a buzzing, and I can now bring in the FM modulation through a control, and you'll hear what that sounds like as I modulate my oscillator by a second oscillator. Just one simple example of how I can use the micro CVC as a CV controller for my ContinuuMini. Or if you wanted to, you can order the other cable that connects the micro CVC to the Continuum. The one I have here connects it to the ContinuuMini, and remember, you just have to make sure you set the I2C on the pedal input to 1 for CV control.